9.1 from question 9 reads, determine the first derivative from first principles if it is given that f of x is equals to 2x squared minus 3x. So the formula for getting the first derivative from first principles is as follows. We get the limit as h tends to 0 for f of x plus h minus f of x all over h. Now f of x plus h is just f of x, but wherever you see x, replace it with x plus h. So it's always better to work f of x plus h on the side before substituting it into the equation. So here f of x plus h would be 2. I see a x, I'll replace it with x plus h squared minus 3. I see x, I'll replace it with x plus h. Then I'll simplify this. 2 multiplied by this x plus h squared. Now you can expand this to give you x plus h, and on this one we can multiply out to get minus 3x minus 3h. And then on this one we would have 2, and then would first solve for these two brackets, which would give us x squared plus xh plus xh plus h squared. And then we can obviously combine xh and xh to give us plus 2xh. And then we still have outside minus 3x minus 3h. Then we can multiply the 2 inside, which would give us 2x squared plus 4xh plus 2h squared minus 3x minus 3h, like that. And then you see if there are any like terms, x squared, xh, h squared, x and h, so no like terms. Then we come back to our original sum, calculating the limit of h tending to 0 of this fraction. This is just a formality. At this point you don't really need to understand what it means, but you can, for added benefit, if you can find other resources online to explain it to you. But for now we just work with it and we'll only use it towards the end. So our goal is to simplify this fraction and then substitute into h 0 when it won't leave our fraction undefined, because if we were to do it now we would have divide by 0, and we know we cannot divide by 0. So we make our substitution. We have 2x squared plus 4xh plus 2h squared minus 3x minus 3h, and this is minus just the normal fx, which would be 2x squared minus 3x. So 2x squared minus 3x, and then this is all divided by h. Then now there are some like terms and things that we can cancel out with each other, specifically the 2x squared and the 2x squared. So this 2x squared and minus that 2x squared. Then we also have this minus 3x, and then we have the minus negative 3x, which will turn into a positive 3x. So those four terms cancel each other out, and then we are left with limit as h tends to 0 of 4xh plus 2h squared minus 3h, and this is all over h. Then what we can do is we can factor out an h from the top. Doing that, we'll be left with 4x on our first term and plus 2h minus 3. Once we've done this, we can cancel that h with that h outside, and that will give us the limit as h tends to 0 of 4x plus 2h minus 3. Now we can make a substitution. To be fair, you're not really making a substitution, but you're approximating the value, as h tends to a really small number, approximating 0. But for all intents and purposes, think of it as substituting 0 into this equation, which would then result in us having 4x minus 3 as the first derivative, like that. So that would be your answer.